Amides are formed in much the same way that esters are, and it can get a little complex, so we're just going to focus on the reactions of a carboxylic acid with ammonia and with primary and secondary amines, and that will form, respectively, primary amides, secondary amides, and tertiary amides. So amide formation, like the formation of esters, involves the carboxylic acid losing its hydroxyl group to react with a hydrogen from the other molecule. So when we react ammonia with a carboxylic acid, we will always form a primary amide. Hydrogen from the ammonia reacts with the hydroxyl from the carboxylic acid to form water, and that amine, or the ammonia nitrogen, forms a bond with a with a carbonyl, carbon from the carboxylic acid. And this primary amide, the easiest to name, based on the acid name, 2 carbons, acetic acid, acetamide. Okay, so we can also form amides from reaction of a carboxylic acid with primary or secondary amines, because both of those amines have hydrogen atoms. And for this reaction to occur, we need a hydrogen to react with the hydroxyl on the carboxylic acid to form water. All right, so here we have on this slide 2 examples. The example on the top of the slide is a primary amine, and then the second is a secondary amine. So the primary amine here has methylamine, and one of the hydrogens from the amine reacts with a hydroxyl from the carboxylic acid to form water. The nitrogen of this amine then bonds with a carbonyl, carbon of the carboxylic acid, and we form a secondary amide. And by secondary we mean that amide nitrogen is bound to 2 carbon-containing groups. So it retains the methyl group that it had as an amine, so we call it N-methyl, and then the rest of the name depends on the carboxylic acid, acetamide. Then let's look at the reaction of benzoic acid with a secondary amine. So the secondary amine has 1 hydrogen, and this hydrogen is going to react with a hydroxyl from the carboxylic acid to form water, and then the amine nitrogen bonds in the place where that hydroxyl was. So now we have a tertiary amide, meaning that there are 3 carbon-containing groups to that amide nitrogen. So N-dimethyl, and then the rest of the name depends on the acid, benzamide. Now there are reactions between carboxylic acids and tertiary amides, and the reaction is a little bit more complex than I'm addressing on these slides, but you're only going to be responsible for the reaction of ammonia, primary amines, and secondary amines with carboxylic acids, and you're not going to be responsible for any of the intermediate steps. You only need to know that high heat is required for this reaction, and that should be good.